What is the Reynolds number in pipe flow? Imagine water flowing through a pipe. Sometimes it moves smoothly, other times it swirls chaotically. What makes it change from one to the other? That's where the Reynolds number comes in. It's a simple way to tell us how the flow behaves inside a pipe. The Reynolds number is a number that compares the force of the fluid's inertia to the force of its viscosity. Inertia is the tendency of the fluid to keep moving, while viscosity is the fluid's internal resistance to flow. To find this number, you take the fluid's average speed and multiply it by the pipe's internal diameter. Then you divide that by the fluid's kinematic viscosity, which is the ratio of its dynamic viscosity to its density. Alternatively, you can use the fluid's density, velocity, and the dynamic viscosity directly in the calculation. When the Reynolds number is low, the viscous forces dominate, and the flow is smooth and layered, called laminar flow. When it's high, inertial forces take over, causing the flow to become chaotic and mixed, known as turbulent flow. Typically, if the Reynolds number is less than 2000, the flow is laminar. Between 2000 and 4000, the flow can switch between laminar and turbulent, called transitional flow. Above 4000, the flow is usually turbulent. Knowing this number helps engineers design pipes better. It influences how much pressure is lost, how heat transfers, and how the flow behaves overall. For example, smooth pipes like glass or copper tend to have lower Reynolds numbers and less friction, while rough pipes like cast iron increase turbulence and friction losses. The Reynolds number also affects how long it takes for the flow to fully develop after entering a pipe, called the entrance length. In laminar flow, this length is shorter and proportional to the Reynolds number, while in turbulent flow, it's longer. So, in simple terms, the Reynolds number is a key tool in fluid mechanics that helps us understand and predict how fluids move inside pipes. It's a vital part of analyzing pipe systems, ensuring they work efficiently and safely.